Introducing the new DigiCert. As the leading provider of high-assurance SSL, TLS, and PKI certificates, DigiCert is all about improving security across the web and IoT. DigiCert is committed to helping customers and partners successfully deploy identity, authentication, and encryption solutions. They'll even help you figure out which certificate you need to secure your web domains, apps, devices, and more. Check out the Cert Wizard tool under the SSL tab on digicert.com. The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Welcome back, everyone, to Paul's Security Weekly. As always, crowd favorite Sven from Netsparker will be talking about some JavaScript-based attacks, as we always love it when Sven comes on the show and shares his knowledge about web application security. Sven, welcome.
Thank you, Paul. Nice to be here again.
Yes, nice to have you, Sven. So what is the topic for this evening?
So we will take a look at some variable content inside JavaScript files. Some especially inexperienced developers tend to include some sensitive data into these JavaScript files for specific users. And this is for some very obvious and not so obvious reasons dangerous. And I will show you how some developers try to protect their secret variables and how an attacker might access their content anyway.
Sounds awesome. Let's do it.
Sure, I will share my screen now with you. All right. So can you see it?
Yes.
I will tell you a few things about the setup. So what we have here is let's assume that this is on attacker.com. We have an external script that will contain these variables with the secret content of the sensitive content, and in a typical JavaScript file and a typical HTML file, this would look like this. We have a script tag here with an external JavaScript file, and then we have some inline JavaScript, and this here will be the content of the external JavaScript file. For example, var secret equals I am a secret. And this is pretty obvious why it's dangerous, because we have this in an external script here. We can't read it actually from JavaScript, but what we can do is we access the variable secret. And I have this very useful inline evaluation tool in Visual Studio Code that just shows what we see here. So we just accessed this variable in the external script from our inline script on attacker.com, which is obviously very dangerous if we want to keep it secret. So this is equal to this. Okay, so what a developer might do is use so-called immediately invoked function expression, also called IFI. And what this basically does is it creates this variable inside a scope, in a function scope. So as you see here, we can't access it anymore from our from our script on attacker.com, and it's basically not accessible for us to read. Yeah. So what would happen if we forgot to use the var keyword? is that we just created a global variable here, even if we are inside a function, and we could still access it. For this reason, JavaScript has a so-called strict mode. Use strict, and let me just restart this here. Hopefully it works. Yes, and it will tell us that secret is not defined, because we can't use a variable like that without the var or let or const keyword. If we would use it now, it would work again, but we couldn't access it. So this is relatively secure. I mean relatively, because there are several ways where this can go wrong. For example, let's say we don't just want to save this value here, right? Because we want to use it for a specific purpose, and sooner or later we have to call on like a browser inbuilt function like alert or something. We want to alert the message. And what we can do now is actually replace the usual alert function with a function like this. Use the value here. Console.log value. What did I do wrong? Oh yeah, okay. So what we just did here was proxying the alert message, then including this script here, and we can now access the secret variable inside our proxied alert function. So this is a relatively good indicator why you should never use something like this, even though sometimes it seems like a pretty obvious thing to do. And there's a lot of other stuff that could go wrong. One technique I want to show you is similar to JSON hijacking. Let's make a variable called API call, which is a function, constructor function.
Sorry, Sven, I think your video froze.
Okay.
Maybe restart it, perhaps.
Yeah.
Oh wait, there we go. Now I can see it.
Okay, good. Okay, so we make a function here and use the secret equals some other secret variable. Can't type today. So API call, use var here, equals new API call, something like that. So this now has a secret property containing this. And what we can actually do here is we can still access it from our attacker.com page, even though it's inside a immediately invoked function expression, uses strict mode, etc. What we can simply do here is using the object prototype, and we define a setter on it. So what a setter is basically when you want to set a property on something, you can type the name of the property here, and then you use a function that will be executed once you access it. What we can do in this function, and that is pretty convenient, is we can actually access the value that was set for this property. Let me show you. If it works, I don't know. Yeah. So what we just did here was proxying, not proxying. We were setting a setter on the object prototype, which means that all other object, like all instances of objects, like what this basically is, that has the setter, and when we set a property called secret, we will access this value, even though it is inside an IFI and all that stuff. So that is also a pretty good way to to steal the sensitive content, even though you would on the first look think that this is quite secure. Another thing, what we can do is, this is a little bit complicated. We have a secret array in this specific example. Oops. This is secret. And we use a for off loop for element of secret array, and then do something with the element. Let's define that quickly. Or do something equals yeah, just some undefined. Basically a function that does nothing. Nothing is this here. So if we would replace that with console log, for example, we would see that this would this for off loop would just give you the actual array element, while a for in loop would just give you the index. So this is pretty handy if you just want to access the actual content of such an element instead of changing it or anything where you would need the index for. So let's quickly change this back. I don't know if this is the most the best way to do it, but yeah. So what we can do here now is a little bit weird. Actually, if I will explain it later, I will just write it down first. Object prototype symbol dot iterator equals function, and then we will first have an index equals 0, and let r equals this. Return an object with next method equals, we can use an arrow function here, I guess. Well, let's use a normal one. And then we return another object with done property, set it to true for now, to avoid some bugs while we write this. And a value.
Sven, I'm sorry, your screen froze again.
Oh, okay.
I was trying to follow along, and then nothing was happening. Oh, there we go. Okay, got it.
Okay, good. Okay, sorry for that.
Screenception.
That's right. Oh yeah, no, there's a lot more code there that I had to try to digest.
Yeah. Okay. Anyway, so we will access this array index plus, and then we will return true if index is greater than array.length. Let me just check if this worked. Equals console.log. Okay, this worked. That is good. So, oh no, I didn't. Okay, I had to use array here instead of object. Still works. Okay, fine. Now this is a lot of code, and I will just explain to you what it does. So we have array prototype array, since we're using array here, secret array that we want to access. And the prototype is again for this array that we create here. We can set a custom iterator. So what this iterator does is exactly the same as what we did here. It just uses the content of the array element instead of its index. And yeah, so all of this stuff is basically just some code that is needed to make this work. And such an iterator basically it lets you define how the for off loop works on a specific array. Or in this case, we set it for all arrays that we create afterwards. And the good thing here is that we can actually access this array right here. And yeah, so we again stole this value from our IFI and all that security measures that we had before.
So basically, even storing an array means you can just iterate through that array. Now, do you have to know, like, how do you know what functions to call and what array is storing the secret?
This works for every array, actually. So even
gotcha.
if there were multiple arrays, we could just store this inside another array and later send it all to our server, like
Gotcha.
if we do it with JSON and fetch. And yeah, so this is also a pretty cool way to steal a value that should only be accessible inside these function expressions. And as you might have noticed already, this is not only useful if you deal with external JavaScript files that contain sensitive info for a specific user, but it is also very, very good for debugging obfuscated code or code that was minified, something like that. But it's very handy to get a better overview over what actually happens inside these arrays and etc. Now, what you could also do, or what you can try to do is go a completely opposite way, like a completely different approach. And we use some regex here. Oops. Like if document.domain would end with .example.com, we would just we would set this variable, and otherwise we would do nothing. And let's check here. It's undefined now. So document domain can't be changed. So even if you would try to set your own document domain to example.com, it would not work. But what you can actually do is use regexp.prototype underscore test equals regexp.prototype.test. And then just proxy this function and just return true always. So since all regular expressions now return true, we just get a problem with this inline evaluation tool. But nonetheless, you can see that also this here just returned the content of the variable. So you can trust some code like this to protect your variables if you set them for a specific user. But you should always take into consideration that it's not the best way to deal with this. What you would usually do to have some secret value you can access from your JavaScript file is just querying some endpoint on your own domain that will contain the secret variable content, and then use that later in your JavaScript file, like using AJAX requests, etc.
Yeah, essentially you need some type of vault, right, to store all of your secrets.
Yeah, and that is best handled on the server side, where the user actually has to query it using JavaScript instead of directly writing these values inside your JavaScript files.
Yeah, because oftentimes an easier way to get those secrets is to reverse engineer the firmware, which sometimes they're in there, or just find a public GitHub repository that contains the code, and there are the secrets because someone committed them.
Dumb.
Oops.
Yep.
Yeah, storing them in your code is never a good idea.
Yeah, exactly.
Or storing them in a config file that you accidentally uploaded to GitHub. Oops.
Speaking from experience, Paul?
No, I've noticed the potential for that situation.
Yes.
They're like, oh,
yes. Speaking of which, one of those from not that long ago was when one of the credit agencies got hacked.
Yeah.
They had one of their developers post a bunch of stuff to GitHub, and it had email usernames and passwords and stuff. And, yeah.
And now, Sven, my question for you is: you wouldn't store these in the database, right? Because you still have similar types of issues, because you still have to access them, right?
Yeah, I mean that it depends on what you want to do with it. If you need to, for example, if you had some API keys or something for your services, then you shouldn't store it in JavaScript anyway. So or anywhere where the user could access it, or where you could reverse engineer it, like you said. But let's assume we have something like account balance or something that you want to. Yeah. So, you don't really want to have these accessible from other websites. So,
Right.
storing them inside JavaScript is a really bad idea.
Yeah.
And,
so you're right. It's not just like secrets for an API, but any kind of sensitive data.
Exactly. So we are on attacker.com to explain this again, and the script we include is from example.com here, and this secret.js file is generated for each user and might contain this sensitive info. So it's basically for each user it's different. If that makes sense.
Mm-hmm. It's awesome. Questions for Sven?
None.
Joff, you good?
I think Joff is good.
You all right, Joff?
Oh, sorry. I had you muted, and I was trying to find my drink, and
I caught you off guard. I'm sorry.
No,
he was looking at the Slack channel. That's what he was doing.
No questions for Sven.
Sven, that was fantastic. Thank you very much. As always, it's a pleasure having you on the show. We always learn a lot. So, Sven, thank you for that. Yes. And with that, we will take a short break, come back, talk about security news for this week.